Welcome to the YouTube channel of Unique World Education. Today we are going to discuss about the topic projectile motion from the chapter grade 11 motion in a plane. So we have seen that in the recent exams it was a repeated question, derive the equations of projectile motion. There is some numericals also came from the topic projectile motion. So first thing we are going to learn how to derive these three equations of projectile motion, and we are going to crack that right now. Be with me, take a notebook, write the heading projectile motion, and first we derive the equation, then we'll go to some numericals from this chapter projectile motion, from the topic projectile motion. So let's go, come with me, be with me, take the notebook, write the first heading projectile motion. Before going into the projectile motion, first we have to discuss about what is the resolution of a vector and what is the relevance of resolution of vectors. So I hope everyone know about the basics of vectors. What is the relevance of vector? Why we need to study about the vectors? That is already discussed in the starting of this chapter. Here we are going to discuss about the resolution of vector, because then only we can move on to the projectile motion. So come with me. First, consider an object. It can be a box or it can be a block, whatever it is. For example, I am just applying a force of 5 Newton in the forward direction, in the upward direction. We know that the net force applied on that object will be 5 Newton and that object may move in the upward direction, correct? And I am just again considering another box of, let it be any weight, and I am applying a force of 5 Newton in the horizontal direction, and we know that it may move in the same direction and the net force may apply will be the 5 Newton. This is a common case. But consider there is box, the same box, but I am applying a force at an angle, any angle theta with the horizontal. Clear? So here I am just applying a 5 Newton which is making an angle theta with the horizontal. So here the 5 Newton will not be that net force acting on that object. So this 5 Newton will be resolved into 2. Here comes the concept of resolution of vectors. Clear? So whenever a vector which is acted at an angle theta, we have to resolve the vectors into horizontal and vertical component. So here 5 Newton is the force I applied on that object with an angle theta, but that 5 Newton will be resolved into 5 cos theta and 5 sin theta. Clear? And the 5 cos theta component will be used on that object to move forward, and 5 sin theta force will be used for that object to move in the upward direction. Right? Let's take an example. For example, I am taking let's see the xy axis here. Okay, one second guys. Yes, I'm just considering a xy axis. All right, and I am applying a force, for example a vector which is 5 Newton, which is of angle 30 degree. So this 5 Newton will be resolved into, we know that 5 sin 30 and 5 cos 30, correct? And here you can see that, okay, that is alright. So I will draw here. This is 5 Newton and this is 30 degree. So that is resolved into 5 cos 30 and 5 sin 30, correct? So what is sin 30? Come on, 5 sin 30 is 1 by 2. So the force 5 Newton now resolved into, so 5 Newton was the force I applied, but that 5 Newton resolved into 5 into 1 by 2 and 5 into cos 30, it is root 3 by 2, and sin 30 it is 1 by 2. So that 5 Newton resolved into 2.5 root 3 and 2.5. Clear? So the net force acting on that object will be the vector sum of, or the resultant of these two vectors. This is the concept of resolution of vectors. It is nothing, guys. Whenever a vector is applied at an angle theta, that vector is resolved into two. One will be horizontal direction, one will be vertical direction, as we like discussed. Clear? So let's move on to the projectile motion. Listen everyone, I am just considering a projectile. For example, I am just taking an XY axis, right? Beautiful XY axis, right? Alright. So okay, so I'm just considering this is x-axis, this is y-axis. Okay. Now I'm just taking, for example, okay, I'm just taking an object. Okay. So that object I'm just projecting from the x-axis, and it is considering it is moving like this. So initially I just projected an object with the initial velocity u. Clear? And we know that u may be making an angle theta with the horizontal. That u we can resolve into u cos theta and u sin theta. The first point we derived. So actually you need to create the 8 equations of projectile motion, the 8 component equations of projectile motion. If you know how to write that 8 component equations of projectile motion, it is very easy for you to derive this equation, right? So just come. First let's see what is the u, that is ux is u cos theta. Is this clear? We just split that u into two. One is the component of u along x-axis, component of u along y-axis. So ux I can write it as u sin theta, uy I can write it as u sin theta. The first two equations we just derived. I hope everyone will be clear about this concept, right? Next, I am taking another point. For example, let this be the point. U cos theta will be there. Okay, u cos theta will be there, but u sin theta will be there, but its height will be reduced. You see this one? And when we are moving forward, you see this one, I am taking a point here, u sin theta will be like this, and u cos theta is always constant. So there was a question asked in the recent exam, the horizontal component of the initial velocity always will be constant throughout the motion of a projectile. So the horizontal component, the horizontal velocity will be a constant velocity for a projectile motion. So u cos theta will be, wherever you are checking this one, the u cos theta will be constant. You see this one? For all the time the projectile motion, u cos theta will be the constant throughout the projectile motion. Is that point clear? Now let's take, okay, we got the initial velocity u, that is u cos theta, u sin theta. Let's take the final velocity v. What will happen to this? So like this we need to create the initial velocity, final velocity, displacement. These 3 equations we need to derive right now. Just listen. We know this equation v equal to u plus at. I will take another color. Yes. So v equal to u plus at. So write this equation everyone. Vx equal to ux plus axt and vy equal to ui plus ayt. Okay. Before that we need to derive the acceleration. So what will be the acceleration? Since the velocity in the horizontal direction is all the time u cos theta, it is not going to change all the time. The horizontal component of acceleration will be 0. If anyone is asking you what is the reason, you can just tell the reason. Horizontal direction, the initial velocity u cos theta will be all the time. U cos theta will be constant throughout the motion. If the velocity is constant, acceleration will be 0. But the y component of the velocity is keep changing. When the ball is going up, the u sin theta keep changing and it is 0. Again it is coming down. So all the time the acceleration is acting towards down, and we are taking it as acceleration due to gravity. It is minus g. I hope we got the 6th equation. Now let's substitute for the vx. So what will be the vx here? Vx equal to, what is ux? U cos theta plus what is x? 0. Clear? And what is vy here? Vy here equal to u sin theta minus ayt. What is ay? G into t. we derived another 2 equations. So how many equations we derived now? 2, 4 and 6. Okay, let's take him to another side, let he be there. So we want, okay. So we just derived u, v, a. Let's move on to the displacement. So what is the displacement equation? We know the displacement equation is equal to ut plus half at square. So what is the displacement in x-axis? Substitute it, uxt plus half axt square, and substitute the ux. What is ux? U cos theta into t. Ax is 0, only x displacement is u cos theta into t. What is y displacement? Uit plus half ay t square. So let this person be, please move on guys, so you be there. Okay, so come write this equation like, okay, yes, so we can write like y equal to u sin theta into t minus half gt square. I hope you clear this equation. So take this equation, this is x, this is the x displacement, this is the displacement in y axis. Clear? So how many equations we derive now? Just take this, ux, uy, ax, ay, then vx, Vy, 2, 4, 6, 8. This is enough to derive the coming equation. So we derived this 8 equation. So I hope you can take the screenshot right now, because I'm going to clear the things right now. 1 second guys. Okay. So I'm just clearing only this portion. So everyone write the first heading, the time of flight. So we are going to derive time of flight of projectile motion. What is the time of flight of projectile motion? Let's see this one. Okay, so what is the time of flight? Nothing. Take that equation. So I'm going to first find the total time of flight. So which equation we need to use? See, I'm taking the y displacement, right? After completing the total projectile motion, the y displacement will be 0. You see this point? At this point, y displacement is 0. Why? Because it is coming back to the ground. So take that clue, y displacement 0. What is the y displacement? U sin theta into t minus half gt square. Substitute that 0 in this equation. You will get u sin theta into t minus half gt square. Take half gt square into the left side. U sin theta into t on the right side. Cancel 1 t from there. What is t from this one? 2u sin theta by g. Yes, the first equation we found. What is this? Time of flight of a projectile motion. It is very simple. If you know these equations of projectile motion, the 8 component equation, we just derived the total time of flight. Then what is the time of flight to reach the maximum height? That will be half of the total time. So we can also find that what is the time to reach maximum height? Just remove that 2 from this equation. What is the time taken to reach the maximum height, or the half of the height will be u sin theta by g. It is very simple, right? We derived the 2 equations. So what we did? We took the y displacement equation, substitute the y equal to 0, we got this answer. Clear everyone? So let's move on to the next one. See this one, I'm just clearing. Oh wait. Okay, I hope you took the screenshot. Now, what is the next one? It is very easy. What is that? Horizontal range. What is horizontal range? 2 steps only required. What is horizontal range? Take the x displacement equation. X equal to, we already got u cos theta into t. Substitute the t as time of flight, you will get the equation. What is that? U cos theta into 2u sin theta by g. Correct. Take the 2 outside. You can write it as 2u sin theta into cos theta by g. Max students, you know that u into, you write like this, 2 sin theta cos theta by g. What is 2 sin theta cos theta? Sin 2 theta. So we can write like u into sin 2 theta by g. This is the equation of horizontal range. So we got the equation of horizontal range as u sine 2 theta by g. This is clear everyone? I'm sorry guys, there's a mistake. U into u square sine 2 theta by g. So this is the final equation you are getting for the horizontal range. Clear? U square sine 2 theta by g. We got the second one. So let's move on. We need to derive one more equation. What is that? The maximum height of a projectile. It is very simple guys, just be with me. What is the maximum height of a projectile? How to find the height of a projectile? Any idea? How to find the height of a projectile? Nothing. Take the y displacement again. What is the y displacement? U sine theta into t minus half g t square. And this is the maximum height we are going to find. And what will be the time taken to reach the maximum height? The time taken to reach the maximum height we already derived. What is that? U sine theta. What was the initial one? 2u sine theta by g. But to reach the maximum height, half of the total time, u sine theta by g. So we can write like u equal to u sine theta into, what is that? U sine theta again by g minus half into g into u square sine square theta by, okay, u square sine square theta by g the whole square. This is clear? What we did actually, I just substituted for the time to reach maximum height, the half of the total time. So I just substituted u sine theta into t. In the place of t, I just substituted u sine theta by g. So what is that? U sine theta by g here and u sine theta by g the whole square here. We got u square sine square theta by g the whole square. Just substituted, you will get u square sine square theta by g minus 1g we can cancel here. We will get half into u square sine square theta by g. What is common here? U square sine square theta by g is common. What is in the bracket? 1 minus 1 by 2. What is 1 minus 1 by 2? 1 minus half. It is 1 by 2. So what is the final answer? U square sine square theta by 2g. This is the height of the projectile. So it is not that much of simple. U square sine square theta by 2g. Clear? U square sine square theta by 2g. It is the equation of maximum height. Clear everyone? So this is how we can derive all the equation. Take the previous slide, you will get that equations. What is that? What is the maximum height? What is the total time? What is the range? It is that much of simple. Now on the next video we will discuss the questions. Okay, so I hope it is very clear. We discussed about the resolution of vectors. Then after that we started with the 8th equation, right? How to write or learn how to write this 8th equation. Then who is the one equation we are taking to derive the two things? The displacement y, substitute equal to 0, you will get the total time. Remove the 2, you will get the half time to reach the maximum height. Then take the y displacement again, substitute the half time, you will get the maximum height. Take the x equation, substitute then the total time, you will get the range. Clear? Okay, thank you all. Thank you. Bye.